Good morning, ladies and gentlemen. Already, I think you already see my title for my presentation. So what's that? Digital Earth and the future Earth. Maybe you should ask me, today we have a meeting talking something about the digital Earth. Why you talk something about the future Earth? Well, you know, about the digital Earth, several years ago, Tim Frostman said, oh, digital Earth is down onto the Earth. Some people say, you know, digital Earth in action, applications is so important. So next year when we have a meeting, digital Earth meeting, people say the same is transformation, you know, transition the digital Earth into some knowledge into the practice. That means, so that's true, we should study the digital Earth, like the concept, like the framework, like the vision, but the most important one, like other kind of science and technology, we should do application. That's very important. So what, my opinion, we should focus on, you know, the tendency right now in the world, what people just look for, what people focus on for what. So what I said, we live on Earth. Now on Earth, what's the biggest program? I can say the future Earth. The future Earth is really, really popular and a big program in the world because of facing us, you know, facing the future Earth, you know, sustainability. So for that, I want to give you the first of all about the future Earth, and the second one say something about the digital Earth and some new vision, and the last one I want to say, you know, how digital Earth supports the future Earth. We are facing the challenge of the global environmental change. So now the ICSU and the different organizations launch the future Earth. So that's research on the global sustainability. I think this one already so many people very familiar for this because already, you know, several years ago, IPCC, you know, have some report just to say you can see right now the global become warmer and warmer. Why? Because globally, you know, the sea level is rising, and globally temperature is increasing, and also you can see snow and cover decreasing. I don't know how about New Zealand, but the North Hemisphere in some places just like this. A couple of weeks ago, I went to Tibet Plateau. I went there, you know, for a field investigation for my ongoing project, space technology for global environmental change study. So there, a lot of, you know, snow cover changed so much. The glacier, 20 years ago, after that place, now the difference. So even in the world, people argue about that global change is really or not. But I believe that, you know, globally the environment is changing. It's my idea. So say something about the global change. One of the important one, say we're facing the challenge of natural disaster. Here you can see, even just in my country, you can see drought, the flood, the fire, and snow, ice, and even, you know, the earthquake, like the Christmas church here last year. So, you know, our colleagues around the world have a lot of the activity and study according to IPCC's report. So the development of some kind of, the concept like the Earth system. So here you can see the climate change, how to realize the temperature change, how to realize the precipitation change and the sea level rise and extreme events like the natural disaster. So also you can see we have the two systems, the Earth system and the human system, because right now, not only as a natural scientist, we realize that not only do natural science, but if you want really to do some the big issue and study the system of the Earth, you should realize that not only natural science is important, but also social science also very important. So the tendency is we should study, the mixture of the natural science and the social science. So here, Earth system and the human system, we have the two systems influence, each other. So talk something about the Earth system science, ESS. So you can see the ISSC and the ICSU, published the report several years ago. Just mentioned about that ESS for global sustainability is a grand challenge. According to that, just to say the challenge, we have the 5, aspects. The first one just for forecasting. That means how about the future of the global environment change and the consequence. And the second one is for observing. And the third one is confining. And the fourth one for responding special for determining institutional, economic, and behavioral changes needed for global sustainability. And the last one is innovation. So that's a great change. Just, right now is September, just half a year ago in London, ICSU have the very big meeting. At that time, release news, then means ICSU and in cooperation with other organizations have the new program or new initiative, Future Earth. The Future Earth mission is coordinate international science to answer climate change and also deliver knowledge to address global change. So next one, you can see what about the Future Earth. The Future Earth is 10 years, the program. The ICSU, is the host for this program, but also work with what I said, the different organizations like International Social Science Council, ISSC. In my institute, I host the International Program Office, IRDR. IRDR just a special study for the natural disaster, but sponsor both for ICSU and ISSC. So you can see the difference. And also the UNEP and the UNESCO and WMO. You can see all of these. So the logo is here. I want to say again, here you can see that just the Future Earth for developing the knowledge for responding effectively to risk and opportunities for global environmental change and supporting transformation toward the global sustainability in the coming decades. So that's the Future Earth, saying again, the research for the global sustainability. Here, say something in detail about the Future Earth. The Future Earth will be the global platform, like our digital Earth kind of platform. So in the future, how about the two platforms work together? That's what I want to say. So this platform that deliver the first one solution oriented research for sustainability. And the second one, effective interdisciplinary collaboration. Here, what I want to say again, across natural and social science, humanity, economics, and technical development, so find the best practice solutions for multifaceted problems. And the third one, the timely information for policymakers. And the fourth one, participation of policymakers, founders, academics, business, and industry, and other sectors of civil society, in co-designing and co-producing research agendas and knowledge. The last one is increase capacity building. Capacity building always is so important. Everybody knows that. So that's about the future Earth. The future Earth, that means the next 10 years, 20 years, 30 years. So people live on the Earth. So everybody should concern about that. So our digital Earth, I think we have the duty to contribute to the future Earth. Then what about the digital Earth? Already here, so many scientists and experts already mentioned something about that. So just now, our president, Prof. John Richard, also mentioned his opinion about the remote sensing, GIS, and digital Earth relationship. So digital Earth still in the very beginning stage because we don't have, some textbook give you very clearly definition about what's the digital Earth. So don't worry. I say, quite often, even to my colleagues, students. So like our other kind of the field, like the chemistry, physics, and mathematics, already 200 years or 300 years, but digital Earth just only a little more, 10 years. So we should have time to study for that. That's why we have the society, Internet society. We have the journal. So all of this is the platform. Purpose is just for provide some kind of the channel to study the digital Earth. So different people really have the different understanding for digital Earth. Here, just a very simple, say how about what's the framework for say something from geographically, and also say something about the modeling. It's a platform. The last one, it's really just 30 years ago. The government mentioned about the multi-dimensional, multi-scale, multi-temporal, multi-layer representation of the Earth. And really it's a broader concept, but generally we can say is a representation of the Earth, giving access to all available, especially reference data, past, present, and the future. And also, so data-intensive science. Later, I really want to say some more about data-intensive science. Digital Earth is just it's a kind of platform. We have the data-intensive science. We can have some new discovery and new innovation. This one just for management and distribution. It's a system for huge amounts of data and processing, and it's a framework for global interdisciplinary research collaboration. So focus on the digital Earth here, especially I want to say something about data-intensive science, especially geodata-intensive science, related to digital Earth. Right now, already you can see we have the different logos, geo, the polar year, so, and even some life science, the platform logo. So see them. All of them, now the international organization, they have the huge amount of the data. So without the data, like John said, later I want to say again, data to information, to knowledge, to decision making. So without the data intensive, so we cannot do some deep study. Without the data intensive, we cannot give some kind of new discovery. So what we say right now also affect the challenge for the big data. The data, we say it's the characteristics. You can see the large amount of the data and computational intensive and long-term data curation and interdisciplinary and worldwide communities and folks and digital networks and sharing, etc., etc. These characteristics of the data-intensive science. Data-intensive science already lost astronomy and genomics and partial physics, including the different fields. But our digital Earth, very closely related to geodata intensive science. So any different fields using data with special attributes, Earth study, like meteorology, oceanography, the land surface, and also something about sustainability study, like sociology and urban planning, disaster monitoring, etc. So here shows something about observation satellites. About 30 years ago in Beijing, when we have a seminar, we discussed about the relation between remote sensing and GIS, and we talk something relation between digital Earth and Earth observation. So my question is, what's the difference between the Earth observation and the digital Earth? The second question, if we don't have Earth observation, where is the digital Earth now? So later, I believe that without Earth observation, maybe without digital Earth, I think I agree with John's idea. So remote sensing provides a great kind of the data for humankind. So that's why right now in the Earth observation field in the world, we have the biggest organization called GEO. GEO, have the biggest the Earth observation initiative, the program called the GEOS. The GEOS mission, can coordinate the international, the Earth observation satellites. Then the goal, finally, can we share all of the data, the satellite data? So if in the future, the people around the world cannot share the satellite data, we cannot say GEO is a very successful mission. So people work together from the 89 countries and EU, and also from the 68 international organizations, including our International Society for Digital Earth. So I think in the future, it's, people can really share all of the data. And here, our ESA colleagues' contribution says something about the data sharing and the data intensive concept, say in the future. Like right now, they have a lot of the data, Landsat, the UniSat, Terra, blah, blah. And how about in the 2020, this place? 2020, we have the data, the 220,000 terabytes. That's the special data. And also in my country, in China, already we have some kind of the remote sensing satellite, but also in the meantime, we have some big plan to launch some more Earth vision satellite. We have a lot of data. CEODE, yeah, I came from the CEODE Center for Earth Vision and Digital Earth. So we have the, several labs. One part of the CEODE is a satellite remote sensing center. In this center, we have 3 satellite data receiving stations located, North China, South China, West China, cover all of the territory of the country, and in the meantime, 70% of the Asian territories. So using the 3 satellite receive stations, we already receive a lot of data since 1986. You can see right now we have the 2.5 million since satellite the data. Not only we're receiving the domestic data, but also a lot of the international remote sensing data. So what I want to say, just we really have a huge data. How to analyze this data? So this is the basis of the science and for our digital Earth and next one for future Earth. Here is an example. How about the data-intensive science? Example about disaster monitoring. Somebody know that, 1976, we have a Tangshan earthquake. And about 5 years ago, we have Wellington earthquake. And just 2 years ago, we have Yushu earthquake. So these 3 earthquakes, you can see what kind of data we use. Here, this one is Earth vision data. And you can see the diagram. In Tangshan earthquake, we do not have very, very few data. And Wellington earthquake, we have this kind of the EU data. And for Yushu earthquake, we have big data, not only satellite borne, but also airborne. So, like, Yushu earthquake, we receive this data, we have a lot of data, then do quick analysis, then data information, then write report to the decision maker. Decision maker send some, people for rescue very, very quickly because based on the big data. So the data is important. You can see that. That's why we say data intensive in the geoscience field, in digital field. It's so clearly and so important. And for this one, data-intensive science, you can see, we can say it's more sensors, more access, and more data, and more infrastructure. That means focus on the data, acquisition of data, analysis data, then transform the data into information, and later for decision making. But for this, what's needed? So we should have the open access policies. I think everybody agree with that. And the data tools need to be allowed to interact. And we need some metadata and standards. And we need some infrastructure. And because, we need to do the data to be stored, move, and use. And when we do applications, we bring it all together. Here, mention something about the Digital Earth Vision 2020. Digital Earth, the concept already about 10 years. Several years ago, we said something about it. So already achieved a great success, but how about the next step? How about the future? So the ISDE, have some workshop and some team study for this. So work for several years, for half a year. Last year in Perth, when we have ISDE 7, Prof. John Richard, our president of ISDE, released the vision. And recently, just like John said, already published 2 papers in the International Journal of Digital Earth and the PNAS. So these 2 the papers give some new vision about the digital Earth. I want to say 2 more. Here say something the history. How about we begin to do this, and what's the key issue about the vision? This digital Earth 2020 towards the vision for the next decades. Just published the IJDE, and the next one you can see this is the very wonderful picture. Here means the digital Earth index represents the state of digital development of each country. So each country position, you can see something. Here, the annual consumption indicator. Here just means the technical index. And another, the paper, the title, Next Generation Digital Earth, published in the PNAS. Here can show that it's the key issue for this article. Last one, how we digital Earth can support the future Earth. I think several procedures, just like the data flow. The first one, you can see, we say the data extraction and information extraction and knowledge extraction and modeling and decision making. And next, you can see for data extraction, we should search engine, like query search index, metadata, as well as the data mining in unindexed sources. And the second, for information extraction, data processing returns information to the user, not just data, not just the data. And the third one, for knowledge extraction, integrating and comparing information help us understand hidden relations in the data. And modeling for long-term time provides the basis for modeling. And decision making, here just for instantly share results and visualization without other users. So finally, to conclude, we can say the future Earth, the concept already beyond some technology, requires policies and attitudes open to share and collaboration. Our digital Earth offers a common framework to tie together data sources, data-intensive science, and the users. Goes beyond correct concept in that it would connect users to each other and provide advanced querying access indices and data types that incorporate processing, that include history, data, and modeling future. So anyway, we want to say digital Earth is powerful for research on global sustainability. That means for future Earth. So thank you so much.